This is Precalculus Lesson 1-4. We're talking about solving sinusoidal models. That basically means it's everything that we've done in 1-3, but now with word problems. So, vocabulary. I should have done this a long time ago, but because our notes are going to be so short today, this is a perfect point to talk about. A peak. This is a point at the very top. So, for example, if I have a peak, I have a peak here at pi over 2, 1, 5 pi over 2, 1. Those are all peaks. So we can label that this thing.
Would also be maximum.
It is also a maximum, yeah. The peak is the maximum of a trig function.
When do you start labeling things with maximum?
In precalculus? Or where? In precalculus, I don't think you ever will. Not at least for this unit, because trig functions, it's pretty boring because they just have a bunch of maximums repeated. But once we start talking about, I don't know what we talk, I guess talking about, yeah, I don't actually know when the next time is because it's a long time away. So don't worry about it for now, I guess. A trough. How do I pronounce this? Trough? Does anyone know how to pronounce this? How to pronounce T-R-U-G-H. Oh, timeout. Stop the music.
Why did you such a trial definition?
Trough.
I thought so. Okay, trough. Okay, so trough. That is a point at the bottom, at the very bottom. At the very bottom. So our troughs are down here. Peak and trough. Not super important words, but it helps us define amplitude and period. So amplitude is the distance from the center line to a peak, or the distance between a center line and a trough. We should label a trough down here too. T-R-O-U-G-H. So this distance between this center line and a peak right here, that is called the amplitude. I'm just going to write, abbreviate with AMP. That is the amplitude. And we can increase and decrease the amplitude. If you're talking about sound waves, the amplitude is how loud it is. How the distance between, or the period, is going to affect the pitch of it. If it's a very high voice or if it's a very deep voice, that will be the period.
Like there's this video that has this like really like windy
High-pitched tone, yeah.
And like I guess that if you put it very high, adults won't be able to hear it.
Yeah, because as you get older and older, your ears are less able to hear because the way that your ear works is it's a little piece of something, flesh, I guess, that vibrates like a drum, and that flesh hardens-ish over time. I'm guessing that's my definition of what's happening there. Amplitude. Anyway,
Does the amplitude always start with 0?
it depends, because if I have a vertical shift, then it won't start at 0. I'm just going to say it's from the center line. So the height from the center to the peak. And finally, the period, which is one of the important things that we're talking about today because it affects our answers. The period, let's do that in green. That is the length between peaks. So, for example, the distance between this peak and this peak, that is the period. And again, the period is what affects the pitch of voice, or the pitch of the noise that's being made. And I guess it doesn't have to apply to sound, it can apply to light. Light is just a bunch of waves. So if they're close together, then it's closer to a blue. If they're farther apart, it's closer to a red. You could talk about what other things are in waves. Electricity, I think, might be in waves. I'm not sure. I don't know enough about electricity to say. Formulas. Okay, so here's a general formula. Let's go ahead and write that down, that this guy right here, he's a general formula. General formula. In the general formula, I'm going to identify two things. I'm going to identify our A and our B. Our C and D, I don't know if I'll ever define those because that's more Algebra 2-ish material. But A and B, they affect the amplitude and the period. So the amplitude is just A. If I have a number out front of the sine or the cosine or whatever trig function, that's going to change the amplitude. That's going to change the height of the peaks and troughs. If I just change this number from like a 5 to a 10, it's even bigger. If I change it to a fraction like 1/3, it's even smaller. All right, so the yes, go for it.
It kind of looks like a formula that has. It was It's like the formula with the x squared plus bx plus c.
Yeah, those general formulas. Yeah, so those are just called general formulas. This is a general formula for a sine function. If I wanted to make it a general formula for a trig function, I would have just said like a box here instead of sine, so it can apply to tan, sine, cosine, cosecant, all the trig functions. This is the important part though, the period. It's 2 pi over b. And I guess if I were redoing the notes, I would have not had those there and I would have had you write it, so writing it is helping you remember. But the period is 2 pi over b. This is kind of just something that you're going to have to memorize, I guess. You just take 2 pi divided by whatever, but in degrees. What do you think this is going to be? Can we write this in degrees? 360 over b, exactly. So write that down as well. So depending on if you're in radians or degrees, that's how you find the period. So if I ask you for the period, you will just do this formula. We're going to get to an example on the backside, but before we do that, here's the process for solving these word problems. So you're first going to substitute. You're going to substitute the value that they give. So just take a quick peek at example 1 with me. For example 1, we have a number that's given here, 220 million. Whatever number they give you, that's what we're going to substitute in for the left-hand side. So substitute the number that you're given for the, we'll just say the left-hand side.
That's funny, that's the same equation that I had last time. They got me very mad.
Oh, is that problem? Yeah, so that means on this problem, how many days later? Well, MT models days, so I'm going to substitute 220, or sorry, T is days, 220 is kilometers. So if MT is distance, then distance is going to go into MT. That's why I'm plugging it into the left. I oversimplified this for you, and I feel bad as a teacher for doing that. I want to make sure we really understand why we're just plugging in this number to the left-hand side. Of course, that's a shortcut, but the long way is because MT is distance, 220 million kilometers is a distance, 220 therefore gets plugged into MT. That's why we plug it in on the left. But every single problem in the problem set tonight is always going to be plugged in the left. And then you need to isolate the variable. So isolate that t. So I'm going to say isolate the trig function. The trig function. And this is stuff that you've already been doing, where you move everything to the left-hand side. So you'd subtract 28, divide by 21, and then you just get cosine of 2 pi over 687, and then you graph that 2 pi over 687. And then you use Desmos to graph the left and right side as two equations. And this, again, is a process that we've done before, where once I move everything over to the left-hand side, once I isolate for that trig function, once I subtract 228 and divide by 21, I'm going to graph whatever number I have on the left-hand side, y equals that number, and then I'm going to graph cosine of 2 pi over 687t. And then 4 is to solve for the variable. And the interesting thing here that changes from last time is on the required interval. So they'll say something like, what is the first time that it happens, or the second time that happens, or sometime in between 2 and 10 minutes that it happens. So make sure that you have it correct for the interval. Let's try an example. I'm gonna wait. Are you good, Daisy?
Yeah.
All right. So here's your example, MT. So let's go ahead and do step 1. We need to plug the number in on the left-hand side. So our new equation becomes what, Daisy? Plugging in that number to the left-hand side, just 220 equals
21 cosine of 5 over 687 t plus.
perfect. Yeah, go ahead and write it down. Thank you, Daisy. Dun, dun, dun. Daisy gets XP. And then Rochelle, this one's up to you. What are the 2 steps to isolate the trig function? What is step 2?
Subtract 228 to both sides, and then after that divide 21.
Perfect. I'm going to do that all in one step because we're in pre-calc now. We know how to do this. If I subtract 228, I should have what over here on the left, Rochelle?
-8.
Perfect, -8. And then you said divide 21 by both sides, so I'm going to have divided by 21. That's equal to cosine of 2 pi over 687 t. Cool. We just finished step 2, which was to isolate the trig function. The trig function is isolated on the right-hand side, and we're going to use Desmos to just graph this trig function. Here's the thing. You can do it one of 2 ways. Yesterday, we were just graphing cosine of 2 pi over 687. The problem with that is that it's going to be this really long, drawn-out function. Or sorry, I think it's going to be, yeah, long drawn-out function, which means you're going to have to change the interval. So you can either just graph this one, or you can just graph cosine of t. You can ignore this until the very end. In fact, I think for this one, because it's such a big number on the bottom, we might just want to graph cosine of t. Let's see. Let's see what happens if we graph either one. So if I go to Desmos, and I start graphing, and I decide to graph y equals negative 8 over 21, that's my first function, and I graph cosine of, let's just do cosine of x and see what happens, versus cosine of 2 pi over 687. 2 pi over 687. Oh yeah, it's a long drawn out function. Yeah, times x. So if I graph this one, it's really, really hard to see unless I change my interval. You'd have to like scroll way out to the point where you can barely even see the function anymore to see where it starts repeating. In fact, just to show you what's happening, I'm going to change the axis from negative 1,000 to 1,000, and I'm going to change the y-axis from negative 1.1. Oh. I had to change this axis crazy in order to find out what was happening with this function. So I think for us, the best thing to do is to just do cosine because we can actually see what's going on. Well, of course, when I go backwards, it looks really weird. But if I go from negative 1 to 1, maybe 10 to 10 would be better. But you can see exactly what's happening. It's intersecting. It's a little bit hard to see. It's intersecting here and here. The only thing, the only problem is when graphing cosine of x, you're going to have this additional step where you have to divide by 687, sorry, to undo it, you have to divide by 2 pi and multiply by 687. So it's an additional step. But it makes it easy because you're graphing the same thing over and over again. You don't have to keep changing your x-axis over and over. So you get to choose. You choose whatever you like better. If you like changing the x-axis so you have less math to do later, go ahead and do that. If you just like using the same graph over and over and just doing the simple calculation at the very end, then do that. I'm going to do both methods, you choose. So in the method where I don't change the x-axis, I just leave the x-axis the same over and over again, I do the following. We'll do the left-hand side. I get the following, which is 2 pi over 687 t is equal to that first intersection. So it's asking how many days later does Mars first reach? Since it's asking for its first time that it reaches that distance, the first intersection point, 1.962, is the answer. So 1.962 1.962. And then from there, I need to solve for t. So now I need to divide both sides by 2 pi, multiply both sides by 687, and I'm going to do that on my calculator because obviously, or just multiply by the reciprocal, which is the same thing all at once. 162, and if I multiply that by 687 divided by 2 pi, like that.
You don't have to add 2 pi because on the other side of the 1.962 times 2 pi. And 2 pi would have canceled each other out.
So the 2 pi, so be careful. So let me write down what you just said. Because this is going to be plus 2 pi here. 2 pi n. And you're saying that when you divide both sides by 2 pi, it's going to cancel each other out. It'll cancel this one out, but it won't cancel this one out because there's 2 terms here that you have to apply it to.
So, okay, so basically you can cancel out 2 pi to 2 pi, but you would have to do a whole 1.962 times 687 over 2 pi?
Exactly, yeah.
But isn't it already canceled out?
You have to cancel it out for each term. If there's a plus or a minus sign, there's 2 terms here, so each term has to be multiplied by the reciprocal here.
So if it was multiplication, then it wouldn't be that way?
If it was multiplying or dividing here, then yes. Actually, only multiplication would work. Yeah, so each of these terms needs to be multiplied by the reciprocal here. So I'm going to come here and I'm going to say, it really doesn't have pi as a number. Okay, I'm going to have to approximate. So I'm going to say 1 point, in fact, I'm just going to go to the calculator. It's easier. Again, make sure that you're not in the simple view, the scientific view. So you can do command 1, command 2. So you have 1.962, and that's going to be multiplied by, and I'm going to start my parentheses now, 687 divided by 2 times pi, end my parentheses, and I hit equals, and I get 217. So on the 217th day, without going to the 218th day, it's on the 217th day, right in the middle, 1/4 of the way through 217th day, that's when it happens. So, I'm saying that wrong. Yeah, but thank you. 2,117. So 2,117. There's a decimal here, but it's on this day that it happens. So the answer is 2,117 day, if I have a th in there. Or if I want to say 2,117 days after the mission begins. So that's the first way of doing it, where you don't have the graph move. If you do decide to move the graph, you'll have to be very careful about how that happens. And let me show you what happens when you do that. Now I'm going to uncheck cosine and recheck this other cosine, which has a crazy long interval. Now I have to go from negative 1,000 to 1,000. And the answer should be 214. Uh-oh. Uh-oh, something happened. Because this should be the same answer that we got here, and it's not. Why is that not the same answer? 687. I did cosine. Alright. Well, obviously it's a teacher error. Let's see if I catch it before someone else does. So that was definitely 214 here. It should be the same answer. Why is it not? So I want to see if you can catch it. 1 to 10 of the cosine function. 1.962. Is it because my decimal was rounded?
Try doing, what was this sign? Right? Cosine?
This was
Try
cosine.
Arc cosine of negative 8 over 21. And use four numbers after the decimal.
Ah, so you think it's a rounding error. But we were off by a huge factor. Alright, yeah, let's try it. So I must have made a mistake on the calculator. I'm guessing that's where it was. So 1.961, and we need to undo this thing. So we need to multiply that by 687. We need to divide it by, in parentheses, 2 times pi. And we get, well, I made a mistake on my calculator because here's the difference. What we got was 217. Oh yeah, so it was around. You're right. but it was still off by a factor of 1,000. I made two mistakes on here. First, I rounded too soon. I should have used more decimal places. And secondly, I needed to do my calculator correct. I just made a calculator error. All right, so Rochelle, log it in your extra credit tracker. I should have done it this way to get that number.
Because for me, I would use like just 1 or 2, and I kept getting it wrong.
214. Yeah, so this one should have been 214.41, which is still the 214th day. This one?
Oh, so you're supposed to do the arc sign?
Well, technically you're supposed to,
Arc cosine, yeah.
but because you already put it here, it's already easier.
Yeah, the problem is that Desmos does not give you enough decimal places just from the graph, so we had to do it out here on the left-hand side. I wonder if there's a way to change how many decimal places it rounds to on Desmos. I don't know if there is. Should we Google it? Is there a way to round to more numbers on Desmos? I don't know. Rounding, or just round. There's a round function, but it doesn't look like you can round anything. So if I'm back to this graph, I can't change this to be more decimal places. And I think I do need more decimal places. So we're gonna have to do it on the side out here, which means I think just for my personal opinion, that this method of changing the axes over and over again are probably the better way of doing it, because you don't have to mess with rounding at all. You just say, oh, click on here, boom. Oh wait, I have to move this over. Boom, my answer is 214.
Go to the settings.
Settings.
Here's 100.
Oh, go to projector mode. Oh wait, no, that's something else.
Yeah.
That maybe.
Zoom square. Oh, that's interesting. Let's undo that though. Yeah, so looks like that is the best way of doing it. But the answer is 214 days. Let's try that method with another problem. Example 2. All right. Step 1, Rochelle. Daisy did step 1 last time. You're doing step 1 now.
Alright. So it's 5.2 equals 1.5 cosine of 2 pi over 365 times t plus 4.3.
Very nice. Make sure I'm giving XP for this problem. All right, Daisy, isolate the trig function.
So you subtract 4.3 on both sides.
Perfect. What am I going to get on the left-hand side?
1.1.
Close.
Wait, what?
No, you're right. You're subtracting 4.3,
Oh.
but you did the subtraction problem wrong.
Wait.
5 point. No, so it's a bigger number minus a smaller number, so it should be a positive.
Oh, it would be point of 0.1.
Not
Wait,
quite.
what am I doing wrong?
0.5? No, wait, no, point.
What happened here?
1.1.
Why did everything just get shifted? I still haven't figured this happens.
5.2.
That's what I said.
Yeah. So this is how I do it. So
Wait, Mr. Sin, I said 1.1.
You said 1.1, but I don't know why all of my numbers got shifted. Do you see that?
don't change the subject.
No. I said it right though. Whatever.
I need to shift all these down. Don't know why that happened.
So
All right.
I guess today, bake this thing.
Oh, sorry, it's not 1.1. It's still not 1.1.
What?
5.2 minus 4.3 is not 1.1.
Oh, it's point 0.9.
Yeah, it's 0.9.
Oh, because you're.
Cool. It is 0.9 is equal to blah, blah, blah. But let's do 0.9 divided by 1.5, yeah? Why did I do that, Daisy?
Because you're supposed to isolate whatever it's called.
the trig function?
Yeah.
So what did I do to both sides of the equation to get
So
that?
you divided 1.5 on both sides. So
Yep.
we use
Perfect. Okay. So that's the function that I have. So I'm going to graph y equals this. I'm going to graph that, and we'll see what happens. So let's do that together. So if I now come back up here, and let's say I had a brand new, let's just go ahead and refresh this and see what happens. Reload. So we have a brand new page as if we didn't do anything. So I'm going to do y equals 0.9 divided by 1.5, 0.9 divided by 1.5. And then I'm also going to do the cosine of 2 pi over 365, 2 pi divided by 365. And I need to make that a function, so I need an x in there, that's why. X, make it my function. Let's zoom out a little bit. Let's zoom out so I have negative 100 to 100. Is that going to be enough? Maybe. It depends on what the question is asking, because I see an intersection point right there, but it's asking, what is the second time? So I'm not looking for the first one, I'm looking for the second one. So I need to zoom out even more. Let's go from negative 100 to just 1,000, I guess. Boom. So there's the first time, there's the second time. The second time was 311. Did we all see that on our own graphs? See if we can get to this point right here.
it doesn't matter if we're in degrees or radians.
Ooh, it does, actually. It said this one was in radians. I think both of them were in radians, right? Yeah, both of them were in radians. What just happened? Everything just got shifted down now.
How do you know?
Because I just underlined radians and I had I had 5.2 right there. I don't know why this program does that just randomly. I need to look that up. But this all should be like that. Weird. Okay. Maybe I need to scroll up and down next time that happens. But yeah, did we all get this on our graph 311? You see that on Desmos on your screen right now? You see the intersection between 0.9 over 1.5 and this trig function? So we get t is equal to 311. 311. Round your answer to the nearest whole day, so rounded to the nearest whole day is just 311 days. Box it. All right. Rochelle, Daisy, did we finally get this graph?
Yeah.
Rochelle? No?
I'm still working.
All right, take your time.
What axis did you put 1.1?
I could have. It would have been better if I did negative 1.11. Negative 1.1 to 1.1. The x-axis I did. You don't have to get this exactly. I just want you to somehow find that second intersection point of 311.
That's what I'm trying to find, but it's just, I think my graph is...
I'm supposed to do the x-axis.
Change your x-axis so the x goes to 1,000.
That's what I did. Freaking Desmos keeps changing.
You might have to hit enter when you...
X-axis instead of the y.
No, like, that's what I think.
What?
All right. I think this is a good point to wrap up the notes.
You're
This
in
is all I
degrees.
have,
You're
so
supposed to be in radians.
that's it, yeah.
There you go.